So Dylan from Pond. So what we are doing is we are developing crypto native models and its relevant infrastructure. So since today is AI day, so how many of you really understand what AI agent is on a high level? So basically, an AI agent is just like you can understand us as a human being. It's the same thing. So we perceive data from the environment, and later on, our brain is the model that learns and processes all the data, and later on we make predictions and we act based on those predictions, and also combining with other outputs or inputs, whatever, to make those actions. So those are basically on a high level what an AI agent is really about. It's an autonomous entity, but it's just a jargon. So it's basically what an AI agent is just a workflow. We come from data, we treat information from data through model, and later on we make actions based on models and other inputs. And later on, this action can or cannot feed back to the data side or to the model side to have a feedback loop. That's what an AI agent is really about. It makes decisions based on data, based on conditions, retrieved from those data through machine learning models, same thing. So that's what it is really about. So we have seen so many projects because the next presentation is about virtuals. So we're going to introduce virtuals first. So the agent is really about models and data. So different models and different types of data create different use cases. Like in virtuals use case, they have Luna, which is the animation. It attracts people's attention. It plays interactions with different people, and people like it. That's the reason why we have virtuals today. And also we have AI XPT, so it learns from the on-chain data and some of the micro on-chain data, and also the Twitter's contextual data, and later on it creates some of the engineering works to make it very fun. Reply error messages as long as people tag them. And we have AI 16Z, which is not very relevant because most of people are from virtuals today anyway. So this is what we can do with Web 2 data and Web 2 models. This is the agent built on top of Web 2 today. So for crypto, what is the data we think is quite unique in this industry compared with what we have in Web 2? It's really about the on-chain data. So what is on-chain data? So the on-chain data, as you all know, we have different nodes. It can be contracts and wallets, and we have edges. And edges pretty much is this interaction between different nodes, like buy-sell transfer. So those two simple behaviors that can later on be combined and have infinite possibilities. That's how we see the price change of tokens, the spam or the security issues, and even the social recommendation on Farcaster. Pretty much everything. So as long as we are dealing with any crypto applications, we are a part of it. So what we can retrieve from this data is going to be the next part that I'm going to introduce a little bit more. So Uniswap and CowSwap, they recently have launched a hook. I don't know how many of you have heard about hook. It's a bit they are the experts. So what a hook is really about. So imagine the time when you trade a token on Uniswap, you have an AMM, right? So people are providing liquidity into this liquidity pool. So that's how you can trade a token from this trading pair in this liquidity pool. But the problem is, probably you haven't really heard about it, is more than 80% of liquidity stakers, they don't make money. What's the point for the market to stake their coins, to provide liquidities, to have so we all can have a lower slippage when we trade tokens on Uniswap, right? So Uniswap and CowSwap, they're trying to solve these problems by introducing a dynamic fee model through hook. So rather than giving you a fixed pricing structure as a liquidity provider, so the time when you stake whatever the token, rather than giving you a 5% or 15% fixed yield, you can have different models or with different approach that you can have a customized liquidity pool channel for you to customize what's going to be the dynamic fee provided to these liquidity providers. It can be 15%, it can be 5%, it can be even 50% in different cases, but it's not going to be fixed anymore. So that was really about. So this is arguably the very first, or what we can see a monetizable use case in the market today, which is invented by CowSwap and Uniswap. They are doing this. So still going back to the the data side. So the time when you can, for example, let's say this is a token contract. This is a cluster of wallets are interacting with this token contract and buying and selling this token. You learn what happens here, right? Based on those profiles of the wallets and also the behaviors of the wallets. So the next time when you see maybe just a quarter of the behaviors here, then you can predict, within the next few hours or within the next few days, it's gonna act in what way. So you can have a condition to a customized Uniswap hook, so they can have a better dynamic fee structure to liquidity providers, just giving a use cases here. So what it takes to develop models trained on on-chain data? Well, in Web 2, we have scale, the structured data sets for different AI companies. And companies like OpenAI, they just use whatever the data provided by those professional data service providers. And later on, OpenAI recently launched their agent, OpenAI Operator. So that's how this Web 2 AI agent landscape looks like. But in crypto, unfortunately, and also fortunately at the same time, is we have to do this by ourselves, alone. And also we are using some of the data service partners. But since we don't have many projects that are doing this on-chain machine learning, which means that we need to do the final push by ourselves. So we have to structure a messy on-chain data by ourselves, not to mention about if you ever want to deal with Solana or Base or any other cheap and fast chains. And also, apart from that, you need to define valuable machine learning problems. Because, machine learning, especially on-chain machine learning, is kind of a new field. What is going to be the valuable problem for people for this industry to have or to solve? Because we can propose lots of problems with machine learning, especially with on-chain data. But what is going to be the valuable one? So that's also the tricky part, which is the model research part. So once you have the research leverage from the data and how you can empower different people to create different models on top of that and find the best possible one, that's another one. So from data to model, and this is what we are doing right now. And for the action, especially the agent part, we are working with other third parties to do this all together since people from Thales just come back. So yeah, we can work with someone like them. So the next step after we have solved the data part and we are going to enter the model and inferencing part. For large language model inferencing, usually they don't need real-time data and they don't need the real-time inference because all the relationship of different words tend not to change forever. Like, I am Dylan or you are here today. This relationship of words won't change for years. But for on-chain environment, it's constantly changing, which means that you need a constant and dynamic inferencing infrastructure to inference those models. So what we are doing is, on one hand, we are defining lots of valuable machine learning problems, like token recommendation model on Base. This is something that we are working with Base, Hyperbolic, and Virtuos, and also other models like alpha prediction or risk management or any other types of models. And this is the models of this competition of Vitalik. He's trying to improve the funding, public good funding mechanism through machine learning. And this is that people are competing with each other. So that's how we can find the best possible model from this approach. After we define them, we introduce the competition so people can compete with each other and we find the best possible model from that approach. Not to mention about the inferencing. Inferencing part is a bit tricky, so don't plan to put it here today. So since I think from the last panel, someone asked how general user can play around those agents. This is some high-level thoughts. This is something that we are working with agent partner to create such a thing. So you see, we have different models here, like T recommendation model for Zora, base token recommendation, 1 hour, 4 hour, 6 hour, etc. Oh, this is not relevant anymore. But let me see this. So we have different models. So different models, they work with each other because everything happens on chain. They don't have data synchronization issue. So imagine today, what is the price prediction of Clanker? I think the time I demoed with Clanker. So 4 models, they are playing with each other and give you a output about what is the token price prediction for Clanker. So general user, they can play and combine different models all together They can create their own use cases, and even this agent can work with other agents in this way as well. So that's possibly the best approach in the market today that allows general users to play around agents and create different use cases. What is next is, as long as you have these models, remember the agent part, like the definition of agents from data to model to actions, and the actions goes back to the model. Those agents will power different actions. Like today, you want to have some sort of like a trading or recommendation. Well, it's no longer one model works at one time. It's different other models orchestrating with each other at the same time to provide you a more moderated and more robust result. And you can feed some of the model results into different applications. Like, for example, the next time when you trade on that screener, you probably don't need to understand or try to guess what happens with different candlestick here. Like, what's the reason behind this token, dumped 5%, or what's the reason why this token pumped, 50%? Everything can be retrieved from machine learning and give you an understanding about what happens on chain, what kind of behaviors cause that, so you can make your investment decisions in that way. Because when we are taking a look at this K chart, we got nothing from it but guessing, right? So this is what the machine learning can bring into you. So some explanation and predictions. Yeah, I think that's pretty much it. So introduce the definition about AI agents and what the crypto native models should look like and will look like and how it looks like today. And also the difficulties and challenges for that and the future AI-powered applications in this industry was going to be the most crypto native ones. So that's pretty much for me today. And any questions? It's going to take a few if you have. You can understand it in that way. So this is a very good analogy, actually. So lots of people, they are talking about it. But the key differentiator is really about the nature of the data. So in Web 2, when you use Kaggle, well, it has proven it works. You can find the best possible model and model development mechanism from that. But the problem is, as a developer, you never own those models because you don't own the data. Right? All the data, they are probably owned by whoever proposed this competition. It's like Google, whatever. So the time when a developer submit their model, they don't own the model. Or even they own the model, they don't own the data. What they have is just a useless piece of code. But in crypto, because technically speaking, on-chain data is public, it's permissionless, everyone owns the data, which means that you still own the model because you own the data. So that after the computation, each model will be deployed on the inferencing network so they can function by themselves. So we can commercialize those models in that way. Yeah. That's it. Yeah.
I have a question. So
yeah.
It's about GPT models. This kind of the language model is the number, but I see you use the percent of increase in the token in the next few hours. So how do you evaluate the percentage accuracy when you use as a GPT model, especially for the
yeah, so GPT, actually each model, the reason why agents limited by the use cases of models is really because models create use cases. So GPT is designed for processing language data, but language data you can process all the Twitter content, but you cannot really apply that into the on-chain environment because it's not designed for that. It's kind of like I'm having an airplane, but I'm trying to drive it on the road. So it's designed for different purposes. So for whatever we are developing here is we are adopting a structure called graph structure, like graphical model. So this is the data structure of the on-chain data. It's like nodes and edges. So as long as the data type can be impressed in that way, it's the type of graphical data. But language model doesn't work. Language itself doesn't work in that way. So yeah, that's the model difference, the model architecture difference. Yeah. Yeah.
How do you use the as
Yeah. So it's a. Yeah, so what you can do is you can leverage different use cases all by once. Like, for the price prediction, the use cases alone, you probably need the combination of token recommendation model here, and a wallet risk scoring model here, and a token risk scoring model here, And you need a volatility prediction for tokens here. So it's not like one model that functions by itself, although you can do, but the model output 100% is not robust enough. So you have all types of models that orchestrate with each other. They can provide a use case for that. And for each different use cases, they have different way to structure this model. Like the price prediction, on one hand, you can structure a model with, I learn all the on-chain behaviors, like different profiles of wallets, how they interact with each other, how they interacted with the smart contract, at what time interval, in what time frequencies. They buy, sell this token, so later on result in this token price to pump 5x in 20 days, things like that. Or you can even have a volatility prediction, try to understand the volume, the correlation of price and the volume of different wallets with the smart contract. So you can structure different ways to structure those models and to power one use case. Because each use case tends to be very broad. So that's the reason why rather than training a large generalized model, we later on adopted an approach that we are focusing on vertical smaller models so they can later on function as a large model.
Yes, so
Yeah.
they are not typically language model.
They are not language model.
Yeah.
Yeah.
What kind of model?
It's a graph model, if you have heard about this jargon, graph. So it's a type of data, it's a typical, technical jargon. Yeah, any questions? If,
You guys the graph model as a post process, as a functional model without for computation?
yeah, because for general user, it's very hard for them to understand the metrics or the outputs of those graph models. So we have to interpret, those outputs as a natural language. Yeah.
How much about the training the time?
It varies. It really depends. Goes back to different use cases. Let me show you some of them. So like the volatility prediction, what do you have here? Well, the data set is quite large, because you are trying to, predict, the volatilities of different tokens, and you need a lot of data to do that. But some of the use cases, like the one with Vitalik, and it's not that large actually. It's just like less than 1 megabytes. So it's really case by case. Yeah, it's here. See it.
Do you have any evaluation on the result?
Yeah, so that's the reason why we introduced the competition mechanism. We have opened up the evaluation after discussion with the community. Let's say for this one, you want to be, the model output should be evaluated in this way. Oh, sorry. In this way. So, can you see it? Oh, yeah, I can see it. So, which means that you need to train your models with, that later on will be evaluated with this metric, and that's how you can have a leaderboard to compare different models, the robustness of different models. Yeah. Right. Thank you for the questions. I guess that's it. Any other thing? Other questions? If that's not, then thank you so much. This Saturday, so try my best to simplify the content, but just let me know if you have any other questions later on.
Thank you.